Welcome to the world of confusing ray diagrams. Most of the students in CBSE grade 10 find drawing ray diagrams confusing. I'm trying to explain how to draw ray diagrams for concave mirrors in this video. Then we will see the nature, position of the images formed by concave mirrors. Then we will go for uses of different concave mirrors, and last, as usual, some numerical questions. To begin with, ray diagrams for concave mirrors. In this picture, you can see an object, there is a plane mirror, and you can see the image. So what I am trying to explain is how to draw a ray diagram to get the position, nature, size of the image. So what is a ray diagram? It helps you to locate the position, size and nature of the image formed. Before I continue, let me talk about different types of images formed. Look at this image. It's erect means upright, head is on top. This is bigger image, which means magnified image. This is upside down, you can see the head down, we call it as inverted image. And this is a smaller image, we call it as diminished image. Draw the principal axis. Then choose a random distance, label it as pole of the mirror. You draw the mirror with the help of a protractor to make it perfect. Keep the right side as the opaque surface and the left side as the reflecting surface, which is silvered. What kind of mirror is this? It's a concave mirror. Why is it a concave mirror? The reflecting surface is inside. So it's a concave mirror. Label principal focus, say 2 centimeter. Then label the center of curvature, another 2 centimeter from principal focus. There are certain rules while making ray diagrams. The first rule, look at this picture. Keep the object, we call it as OB. We draw a parallel ray which is parallel to the principal axis. And the rule says the parallel ray parallel to the principal axis after reflection passes through the principal focus. Rule number 2, it states a ray from the object which passes through the center of curvature of the mirror follows the same path after reflection, which means the ray goes through C and then it bounces back through the same point. The third rule states a ray that passes through the focal point after reflection from the mirror, it becomes parallel. It goes through the principal focus and then it bounces back, which is parallel to the principal axis. A ray that falls at the pole bounces back by keeping the same angle with principal axis. We don't use all the 4 rules to draw the ray diagram. We just follow any 2 of the rules. So what I said, I repeat quickly. Rule number 1, incident ray is parallel. After reflection, it passes through the principal focus. Rule number 2, incident ray passes through the center of curvature of the mirror. After reflection, it bounces back through the same point C. Rule number 3, a ray that passes through the principal focus, it becomes parallel after reflection. And rule number 4, a ray that passes through the pole of the mirror bounces back keeping the same angle of incidence as the angle of reflection with principal axis. Now let us draw certain ray diagrams where we keep the object beyond C, center of curvature. Same, draw the principal axis as I said before. Label the pole P, then keep the protractor, draw the mirror. This is a concave mirror. Label principal focus with a ruler, approximately 2 centimeter. Then label center of curvature, another 2 centimeter from principal focus, and keep the object away from the center of curvature of the mirror. And you can see OB is the object which is beyond the point C. Rule number 1, draw a parallel ray and it passes through the principal focus after reflection. Another ray, your choice. Let me draw a ray through focal point. It becomes parallel to the principal axis after reflection. And where do they meet? They meet at this point where you get the image. I label the image as IM. So what you see here, the position of the image is between C and F. When you keep the object beyond C, the image is formed between C and F. And what's the nature? Is it real or virtual? It's real. Why is it real? You can see the 2 rays after reflection really meet at this point. So the image is real. And is it upside down or upright? You can see the arrowhead is pointing down, so it's inverted. Is it bigger or smaller? You can see it's smaller, so we call it as diminished. So these are the three characteristics of the image formed when the object is kept beyond C. We draw another ray diagram where the object is kept at C. Same, draw the principal axis, draw the concave mirror, label the point, the focal point C, and keep the object exactly at C. Rule number 1, draw a parallel ray. It passes through the principal focus. Rule number 2, draw a ray through principal focus, and it says it bounces back parallel to the principal axis. This is the point where they meet. You get the image at that point. Let's see the position of the image formed. It is exactly at C. Let's see the nature of the image. You can see the two rays really meet at the point M, so it's a real image, and the arrowhead is pointing down, which means it's inverted. And look at the size of the object, height of the OB and height of the IM image, they are the same. So conclusion, when the object is kept at C, the image is formed at C, it's a real image, it's inverted and same size. Third situation, where the object is kept between F and C, same as before, principal focus, mirror, P, F, C, label them and keep the object between F and C. Follow the rule. Rule number 1, parallel ray, parallel to the principal axis, passes through the principal focus. Rule number 2, same rule, a ray passes through the principal focus. After reflection, it becomes parallel. This is the point where they meet, where you get the image IM. Now let's see the position of the image. The image is formed beyond C. Nature, since the two rays really meet at the point M, the image is real. Since arrowhead is pointing down, inverted, and you can see height of the image is more than height of the object. So magnified. Next, object is at F, same as before, principal axis, concave mirror, all the 3 points, and keep the object at exactly at F. Rule, parallel ray, passes through the principal focus. Second rule, unfortunately we changed the rule now. The ray passes through C. Look at this. The ray bounces back through the point C. Look at the two rays. Are they parallel? Yes, the two rays are parallel. Reflected ray that passes through F and the reflected ray that passes through C, they are parallel. And you know in math, parallel rays do not meet. We say they meet at infinity. So where is the position of the image? The position of the image is at infinity. So when the object is kept at F, the image is formed at infinity. Nature, I said the rays meet at infinity, which means real image. And if they meet at infinity, it's inverted and it's going to be much magnified, highly magnified. Next one, the object is between pole and the focal point. Same, principal axis, the mirror, the 3 points. Now the object is kept between principal focus and pole of the mirror. Same rule, ray parallel to the principal axis, passes through principal focus. The second ray through C, so it bounces back through the same way, which means through C. Look at the reflected rays. Are they parallel? No. Are they going to meet? No. You can see they are diverging. Diverging means they are moving further away from each other. So they are not going to meet, which means you are not going to get a real image. So what do we do next? We draw backwards, straight lines. We extend this one backwards. We extend the other ray also backwards. And you can see those two rays meet, supposed to meet at that point. Not really. And there you get the image. Let's see the position of the image. Where is the image formed? Is it in front of the mirror or is it behind the mirror? It's behind the mirror. Nature, is it real? Do the rays really meet after reflection? No. So it's virtual image. You can see the arrowhead is pointing up. So it's an erect image and you can see it is magnified. Remember, if you keep the object in front of the concave mirror, you get an erect magnified image just behind the mirror. This is the principle behind a shaving mirror. You can see the magnified image behind the mirror. And the last one is object is at infinity. Same as before. Draw the principal axis. Draw the mirror. Label the points P, F and C. keep the object at infinity. Object is at infinity means the rays are parallel. Look at one of the rays parallel to the principal axis. It passes through principal focus. Another parallel ray that also passes through the principal focus. You can see the two rays meet at focal point. So the position of the image is at the principal focus when you keep the object at infinity. Now the nature, since the two rays really meet at the point, the image is real and it is inverted. Remember, all the real images are inverted. So the image is inverted and it is highly diminished, very small in size. Let's revise all the mirror ray diagrams in less than 3 minutes. First one, position of the object at infinity. Position of the image is at principal focus. Size of the image highly diminished. Nature of the image real and inverted. Second diagram, when the object is at principal focus, the final image is formed at infinity. Size of the image highly magnified and nature of the image real and inverted. Third one, beyond C, which means beyond 2f, the position of the image is between f and C. Size of the image diminished, real and inverted, the nature of the image. Next, the object is between f and C. Position of the image beyond C. Size magnified, nature real and inverted. When the object is at C, the image is also formed at C. Size, same size, nature real and inverted. All the images are real and inverted until now. And then when the object is between pole and principal focus, you can see the rays do not meet. So the image is not real, which means virtual. And where is the position? Behind the mirror. Size magnified and nature, as I said, virtual, and always virtual images are erect. Next is a question. The question says you have a focal length 10 centimeter. The question asks you where you have to keep the object to obtain an inverted and same size. Same size means the object has to be kept at C, which is radius of curvature, and see the red. And the question says focal length is 10 centimeter and we have to find C, which is center of curvature. The formula we use is R equals 2F. 2 times F is 10 centimeter. So 2 times 10 centimeter, the object has to be kept 20 centimeter in front of the mirror, which is its center of curvature. Next question is, they wanted an erect image using a concave mirror. And remember, in case of a concave mirror, we get an erect image when the object is kept between pole and focal point. And here, the focal length is 15 centimeter. So the object has to be kept within 15 centimeter, less than 15 centimeter from the mirror. And the second part of the question, they're asking what is the nature of the image. The image is magnified. Third part of the question, the image, is it larger or smaller? Image is larger. And they wanted a ray diagram, which we did before. Keep the object between F and, as I said before, draw a parallel ray which passes through the principal focus. Draw another ray through the center of curvature. We know it bounces back. Since these two rays are diverging, draw backwards and those rays meet at this point where you get the image. Since the rays do not meet, you get a virtual image which is behind the mirror. The next question says, an erect and enlarged image is formed. Erect and enlarged image is always formed by a concave mirror. She places the mirror 15 centimeter mark. And the question says, a well-defined image of a distant tree, which means the object is at infinity, is formed at 35 centimeter mark. So this is the 35 centimeter mark, which we know, which is the principal focus. And 15 centimeter is the pole. And the question asks you, find the focal length and name of the mirror. I told you, name of the mirror is concave mirror. And the focal length is, as you know, distance between focal point and pole of the mirror. How far are they? This is 35 centimeter and this is 15 centimeter. Difference between the two, 35 take away 15 will give you 20 centimeter. And the next question is, why is she getting a sharp image of a distant object at 35 centimeter. So the answer is simple. The rays coming from distant object are parallel to each other, and after reflection all these rays meet at the principal focus, which is 35 centimeter mark. Next is a homework for everyone. Read the question and write the answer in the comment box. Thank you.